Okay, I'm going to do my absolute best to make this video as clear and concise as I can, because I have a feeling you may have to come and watch it more than once. Okay, so let's start with this point right here. Okay, and I know when you look at that, you're like, cool, easy peasy, relative max. And you're right. But let's be more specific. Let's say that the x value that goes with that is a, which makes this ordered pair a f of a. Okay, so we're going to put that as our location, a f of a. Okay, and the little comma is sort of for your reason, or how do you know? Because you can't just say, oh, I looked at it and that's how I know. No, it's because the derivative of this function at a specifically equals 0, meaning the tangent line right here equals 0. Okay, so now let's focus someplace else. Let's focus our attention right here. And sort of similarly, you're looking at that and you're like, oh, no problem, relative min. And you're right, it is a relative minimum. But let's be more specific. Okay, so let's call this spot on the x-axis B, which makes that ordered pair B f of B. Okay, so this blank right here, we're going to call B f of B. And then this last blank over here is our justification, our reason. And the reason that we know that that's a relative minimum is because the derivative, or the slope, at that point equals 0. Again, slope equals 0. Okay, so now we are going to talk about when the slope is positive. Okay, so because we're talking about positive, we're going to say that f increases. Okay, it is increasing, it is rising from left to right. This is where, if this was a roller coaster, you would be climbing. This is where you would be hearing tick, 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 tick. And you can see that that happens from negative infinity all the way to a, along with b to infinity. Okay, and the reason is because the derivative at all that range of values is positive. Okay, and then we can talk about decreasing. And using that roller coaster example, this is where you're falling. This is where you don't hear chick, chick, chick anymore. Now you're hearing, ah, right? You're screaming on the way back down. And that is happening from A to B. And that's because the derivative is less than 0. It's negative. Okay, so I'm going to grab a highlighter here. Okay, highlighter. That's not a highlighter. That's a highlighter. Okay, and I'm going to try to draw a picture of these two situations. Okay, so we said from negative infinity to a that the slope was positive. So positive all the way to a. And then between a and b, we said it was negative. And then from b to infinity, we said it was positive again. That I just drew is a graph of the derivative. The green is derivative. Okay? Now, I'm going to switch colors on my highlighter. Okay? And I'm going to talk about concave down. Okay? We talked about this a little bit in yesterday's lesson. It's concave down here. And that's very hard to see. Hold on. Let's try this again. Concave down. I'm highlighting the graph in pink. Concave down. Okay. Let me write that down. Oh, and I shouldn't be writing in green. I probably should be writing in pink. Concave down. Okay. And I'm going to call this point right here where it stops being concave down, I'm going to call that C. Okay, the letter C. So that I can say that from negative infinity all the way to C, we are concave down. And the reason is that the second derivative is less than 0. Okay, and then back to my highlighter. I'm going to use maybe blue on this. From here up, this is concave up. This is where if I was trying to pour water in there, it would actually stay, right? Hopefully it would stay. And let's call that concave up. And that's happening from C to infinity. And the reason, right, we need to have a reason on all these things, is that the second derivative is greater than 0. Now, I'm going to draw one more graph in highlighter of the concavity. Okay, so this is what I'm going to try to graph next. Okay, so from negative infinity to C, it should be negative. And from C to infinity, it should be positive. Okay, so that in blue is the second derivative graph. Okay, so something else to point out. There's a lot of stuff in this lesson, you guys. F of x, the original, I should not be writing in blue. Here we go. The original, hopefully you can see, is a cubic. The first derivative, that's what I graphed in green highlighter up above, is a quadratic graph, right? It's a parabola. And then the second derivative is linear. Okay, so what's happening is that each time you take a derivative, it loses a degree. And it becomes one less degree. Okay, so now I'm looking at example number 1. And it says that this is the graph of the derivative. Okay, so I want to make sure over here that I'm going to label that fairly large. This is the derivative. Okay, and I'm going to grab a highlighter really quick. And I want to remind you that everything that's below the x-axis, all of this below, this is all negative. Those are all negative slopes. And everything that's above the x-axis, those are all positive slopes. Okay? Which means this point right here is where it changes from negative to positive. That on the regular graph, because I need to graph the original graph down here, this is supposed to be a minimum at that particular spot. And right here, it changes from positive to negative. That's a maximum. And this spot where it changes from negative to positive is a minimum. And this spot where it changes from positive to negative, that's a maximum. Okay, so I'm going to draw in, let me see if I can do this fairly well, hopefully. I'm going to draw in some dotted lines so that I can get these to line up fairly well. Okay, so let me see if I can do this in like kind of a light gray. Okay, here we go. Okay, so now using those little dotted gray lines, sort of as guidelines, I'm going to try to draw an original function that has mins and maxes where they're supposed to, based on those little gray lines. So I need to have, let's see, a minimum, and then a maximum, and then a minimum, and then a maximum. Okay? So that's how I can draw an original function given the derivative. Okay? So now, I also have to try to draw the second derivative. Okay, now the second derivative, I'm going to keep looking up here at where these maxes and mins are, because those will become my zeros. Okay, those spots will become my zeros. And I'm going to draw in some more gray lines as guidelines. Now, I know that's a lot to see, but I'm going to draw them in pink. So this maximum is now going to be a 0. And this minimum here is now going to be a 0. And this maximum right here is going to be a 0. Okay. And I'm looking at these slopes. This whole thing, I'm looking at the black line. That has a positive slope. So it should be up top. This all has a negative slope. That should be down below. This has a positive slope. That should be above. And all of that has a negative slope. That should be down below. Okay. Now, again, you may have to watch that for a while. But there's something else that I want you to notice. I want you to notice that on the purple graph right here, this gray line is going through a point of inflection. And this gray line is going through a point of inflection. And this gray line is going through a point of inflection. Right? So if you're trying to go from the original function all the way down to the second derivative, the points of inflection, those big blue dots, become your zeros. Points of inflection on the original become zeros on the second derivative. Okay, again, you may have to watch this a couple different times. Let's move on to the next page. Okay, so for example 2, you just have to look at this graph and see if you can answer the questions. So I'm going to encourage you, pause the video, answer all 6 of those questions, and then unpause. Because when you do so, the answers are going to all magically appear. Okay, please come in and see me if you don't know where I got those. Okay, so now this is asking you some very similar questions, just not with words. Okay, this is asking you, do you know what these symbols mean? Right, because I can tell you right now, the AP exam is not going to say the words concave up. Instead, they're going to tell you this, right? And they're not going to say increasing. They're going to say this. So you need to be able to put the symbols together with the concepts and then be able to analyze the graph. So again, look back through what we've already done. See if you understand. Try these problems and then come back here and unpause. I'll give you a minute. All right. Moving on to the next page. Okay, in fact, this is the exact same picture, but the words are kind of different. And I'm going to highlight some stuff. Mostly because I want you to realize this is the graph of the derivative, not the original function. So let me highlight some stuff. Okay, so now that I've got it highlighted, hopefully this is a little bit easier. It's increasing from -2 to 0, along with 4 to infinity. It's decreasing from -infinity to -2, along with 0 to 4. The x-coordinates of the local extrema are at -2, 0, and 4. And then somehow mine doesn't have it typed on, but I know yours says the x-coordinates of the point of inflection. That would happen at 2 and at -1. All right. I highly encourage, label this graph a little bit more, right? Maybe you're not getting this problem because you forgot that this point right here where the slope changes from negative to positive is a minimum, right? And this point where the slope changes from positive to negative is a maximum. Okay, again, you need to be able to label the graph. Okay, you need to understand the symbols I highly recommend you either watch this again or come in and see me. We'll be doing an activity in class. Okay, good luck.